Most software failures don't start in the code. They start before the first line is written. And what makes this dangerous is that you usually don't realize you're failing yet. You're shipping, you're moving fast, people might even be complimenting your velocity. But underneath that momentum, the system is already accumulating ambiguity, the kind that later turns into rewrites, outages, churn, or marketplace chaos. So in this video, I'm going to walk through the decisions that matter more than the code, the ones that quietly determine whether your system survives growth or collapses the first time reality touches it. Here's the mindset shift. Code is not the product. Code is the enforcement mechanism. It enforces decisions, it enforces constraints, it enforces rules. And if those rules aren't clear, code doesn't fix that. It just makes the confusion run faster. Two engineers can write different implementations for the same system. That's normal. But if two engineers disagree on what the system is, that's not a coding problem. That's a systems problem. So the mental model I use is simple. Questions become decisions. Decisions create constraints. Constraints become code. If you reverse that, if you start with code first, you're deciding constraints by accident. And accidental constraints are where SaaS products quietly die. The first decision is the boundary. Every system has a boundary whether you define it or not. And if you don't define it, the boundary expands slowly and visibly until your system becomes responsible for everything. This is how products turn into unmaintainable platforms. So I ask two questions early. What is the system responsible for? And what is it explicitly not responsible for? Here's a neutral example. Imagine you're building a scheduling system. Is it responsible for negotiation, pricing, enforcement, or is it only responsible for coordination and state tracking? If you don't decide this early, feature requests start creeping in. Can users negotiate inside the app? Can we add dynamic pricing? Can we penalize cancellations? Can we resolve disputes? And suddenly, a scheduling tool becomes a billing system, a trust system, and a legal system, all by accident. We've seen this play out in real companies. Early versions of Uber didn't struggle because of scale at first. They struggled because boundaries between dispatch, pricing, and trust weren't clearly separated. Changes in one area caused second-order effects everywhere else, not because the engineers were weak, but because the system boundaries were blurry. Senior engineers don't just say no. They say, not here, not in this service, not in this life cycle, not yet. Clear non-goals prevent scope creep from becoming architecture. Decision number 2 is language. Before databases, before APIs, before UI, you need to name what exists in the real world. Because names aren't labels, names are contracts. If you call something an item, you imply it's generic. If you call it a request, you imply intent. If you call it an assignment, you imply responsibility. And each of those words implies a different life cycle, whether you define it or not. Here's the trap. Teams choose vague names because it feels flexible. Let's just call it a record. Let's just call it an entry. But vague names don't create flexibility, they create ambiguity. And ambiguity shows up later as edge cases, inconsistent behavior, and endless debates about what should happen. A classic example is Facebook's early advertising system. The difference between a draft, a live ad, and a paused campaign wasn't always explicit early on. and advertisers paid for it through inconsistent delivery and trust issues. When names are vague, enforcement becomes inconsistent, and inconsistency is what users remember. If you can't describe your system cleanly in words, you can't encode it cleanly in code. Once names are correct, behavior becomes obvious. And when behavior is obvious, code becomes boring. That's a compliment. Decision 3 is invariants. Invariants are rules that must never be broken. Not ideally, not most of the time, never. Frameworks change, databases change, languages change, but invariants outlive all of that. A task can only be completed once. A submission cannot be modified after confirmation. A request cannot be accepted by multiple parties. Time-based rules don't move backward. Here's why that matters. If invariants aren't explicit, bugs become policy. The system eventually does something weird under load. And now you have to decide whether that weird behavior becomes how it works. That's an expensive place to make the decision. We've seen this play out publicly. Robinhood ran into serious trouble when trading invariants. Who could trade, when, and under what conditions were enforced inconsistently under pressure. Once behavior shifted, reversing it wasn't just technical, it became regulatory, reputational, and extremely expensive. Invariants don't just protect systems, they protect companies. The senior move is to define the rules your future self will be forced to defend. Decision 4 is failure first design. Most teams design happy paths. User signs up. User does the thing. User pays. Everything works. But real systems fail in boring ways. Nobody responds, something times out, an action repeats, 2 events arrive out of order. Here's the line to remember. Silence is a system input. Time is business logic. If nobody responds, what happens? Does the request expire? Retry? Escalate? Refund? If a cancellation happens, who absorbs the cost? The user, the provider, or the platform? If you don't define failure paths, users will discover them for you. And when users discover undefined behavior, they stop trusting the system. Not because it's broken, because it's unpredictable. Stripe is often cited as a counterexample here. Their early focus on explicit failure modes, retries, idempotency, clear error states is why developers trust them with money. Not because payments are simple, but because failure is designed, not ignored. Decision 5 is restraint. One of the most senior decisions you can make is not yet. Systems collapse when they try to be complete instead of correct. So early on, I explicitly choose what I'm not solving. Not optimizing yet, not automating yet, not adding AI yet, not building for scale yet. That's not laziness, that's sequencing. Because if you don't understand how the system behaves, advanced features amplify confusion, not value. None of this requires a framework, none of it requires a language, it requires thinking. And if you make these decisions early, your code becomes simple, testable, and scalable because the system itself is coherent. In the next episode, we'll talk about why starting with the tech stack is usually a mistake and what to do instead. This is Systems to Code. I'll see you in the next one.